All right, so welcome back. We're going to continue our foray into regression modeling. And so we spent the last video talking about just exploring data if we have two quantitative variables. And so we talked about scatter plots, we talked about the correlation. And now we're going to move into more specifically, well, what is this regression model that we've been referring to? And so you could think about this regression model as just fitting a line to the points in the scatter plot. And so, for example, like we could think about just trying to do this by hand, or just by, I'm jumping back to the scatter plot on page 2, just using our own eyes, kind of judging like, okay, well, if I were to fit a line to these points, what would my line look like? So take a moment to kind of draw a line and that you think fits these points the best. Okay, and so I'm just going to draw a line like, I don't know, like that. So that's my kind of fitted regression line. Now, the handout kind of prompts you to compare the line with the person sitting next to you, so can't do that. You could compare it with my line though. And so is the line that you drew and the line that I drew, while they might be similar, they shouldn't be exactly the same. And so kind of the point of this is that, well, we don't just want to all be drawing our own regression lines and getting different conclusions or different predictions. We really want a way to fit a line that is the best fit line. Best for now is going to mean that we want points as close as possible to the line. But we're going to note here that later we're going to have a more formal definition of what best means. So for now we're just thinking about, okay, we want the line that kind of gets the points as close as possible to that line. And so for now, again, the line of best fit is just given here in this plot. So you could see it, that's this best fit line. We don't really know what best means yet, except it's doing kind of a good job of keeping the points as close as possible to the line. And so the line that's kind of best fit here should be a little different, but somewhat close to the line that you drew by hand. So it's a little different, but should be somewhat close. So we don't just want a picture though, we want to describe what's happening also with numbers. And so that's where our regression model comes in. And so we're just going to define it first, and we'll talk about some of the components in a second. And so our regression model, we're using the same notation as our textbook. And so the intercept is, this is said like beta. So it's the Greek letter B, essentially, called beta. And the slope is a beta with a little 1 underneath. And so let's define what all this crap is. And so y is going to be what our response variable is. In this example, it's course score, so it's on the y-axis. X, we're thinking about as our either predictor variable or explanatory variable. It's called either one. It's what's on the x-axis in our scatter plot, so attractiveness here. The beta 0 or beta naught is our intercept, and the beta 1 is our slope. Similar to the model that we had before, each observation also gets their own error. And similar to the model that we had before, we're denoting that error epsilon. Okay, so we need to estimate this intercept and we need to estimate this slope using our data. For now, we're not talking about how those are estimated. We're just saying that the estimated intercept is 3.79. The estimated slope is 0.09. These should match with the fitted line above. Now is probably the best time to review a little bit about what an intercept actually is. And so this is kind of like prerequisite knowledge for this class, but I think it doesn't hurt just to remind ourselves that an intercept of a line is just where the line crosses the y-axis. Or you could think about it as the value of the predicted response when x is 0. Graphically, the intercept is just whatever the y value is when x is 0. And so in this example, that's going to be our intercept. The slope of a line you might have learned as like this rise over run. I never really liked the rise over run. It's kind of confusing to me. But the slope is just the change in y for a 1 unit increase in x. In other words, if we moved up x from 5 up to 6, what is our change in course score based on this line? And so in this example, our slope is telling us that that change is going to be 0.09. So as x moves up 1, so maybe as x moves from 4 to 5, we would predict that the course score would increase by 0.09. These are just going to help our interpretations make a little bit more sense. So when we go to more formally interpret the slope and the intercept, these will kind of be why we're making those interpretations. Okay, and so we'll leave off here. This was just an introduction of the regression model, and next time we will talk about prediction.